Hello. Today we're going to discuss the difference of squares method, which is a technique for factoring an expression where one perfect square is subtracted from another. Before delving into the difference of squares, we need to discuss what a perfect square is, because it's at the heart of understanding the difference of squares formula and when to use it. A perfect square is an integer that is the product of an integer multiplied by itself. So I've color-coded it for simplicity. If we look at the easiest example, 1. 1 is the product of the integer 1 multiplied by itself. If we look at 4, 4 is the product of the integer 2 multiplied by itself. If we look at a different perfect square, say 36, 36 is the product of the integer 6 multiplied by itself. Now, to make sure you properly understand, let's look at two examples. First one, is 100 a perfect square? The answer to this is yes, because 100 is the product of the integer 10 multiplied by itself. Is 15 a perfect square? No, because no integer can be multiplied by itself to give 15. Alright, now let's look at the difference of squares formula. This formula says that when one perfect square is subtracted from another perfect square, it can be rewritten as the square root of the first term plus the square root of the second term multiplied by the square root of the first term minus the square root of the second term. Now, this may all seem a little bit confusing, so let's look at an example to clarify things. If you're asked to factor the following expressions using the DOS technique or the difference of squares technique, well, first you need to identify whether these two terms are perfect squares or not. So for the first term, x squared, it is a perfect square because x squared is equal to x times x. So the value x, when multiplied by itself, x, yields x squared. Now, same thing for 10. As we saw before, 10, or same thing for 100. 10, when multiplied by itself, yields 100. So now, using the formula, we have that a, which is x, plus b, which is 10, times a, which is x, minus b, which is 10, is our answer. Okay, now let's look at another example. 9x squared. So again, we need to determine if there are two identical values that when multiplied yield 9x squared. This actually just consists, like I mentioned before, of taking the square root of this value. So if we take the square root of 9x squared, we get 3x times 3x, meaning 9x squared is therefore a perfect square. If we do the same thing for 4, we get 2 times 2. So 4 is therefore a perfect square. Now, let's rewrite this. Recall that we have the formula a plus b times a minus b, where a is the square root of the first term and b is the square root of the second term. So we get 3x plus b, which is 2, times 3x minus b, which is 2. Moving on to our final example, which is a little bit more difficult, we have 16y to the power of 4 minus 81. The same idea holds. What two identical values, when multiplied, yield 16y to the 4? Again, this consists of taking the square root of 16y to the 4. When we do so, we get 4y squared times 4y squared. Why? Because 4 times 4 is 16. Y squared times y squared is y to the 4. Then for 81, this is a little bit simpler. We get 9 times 9. Now, let's use our formula. So we have square root of a squared, which in this case is this. So we get 4y squared plus b, which is 9, times 4y squared minus b, which is 9. We are actually not done with this problem yet, as this 4y squared minus 9 also happens to be a difference of squares. So we use the same method as before. What two values, when multiplied, give us 4y squared? Well, we have 2y times 2y. Same thing for 9. What two identical values, when multiplied, give 9? We have 3 times 3. So we can rewrite this as 2y plus 3 times 2y minus 3. So our final answer is 4y squared plus 9 times 2y plus 3, 2y minus 3. And that's it. You've solved a few difference of squares problems. It definitely helps to practice these because you should be easily able to identify when we can factor using the difference of squares method. Whenever you see that you have two perfect squares subtracted from one another, you should automatically think to use factorization with this method.